All right, it says use the table at the left for questions 1 and 2. Survey results of the number of TVs in a house. So question 1. If 275 students took the survey, how many can be expected to have 3 TVs in their house? So then we go ahead over here in this diagram and we look at the percentage that have 3 TVs in their house. And you can see that it is 23%. So you're going to turn that 23% into a decimal. First off, you're going to write your 23. It would be the same as 23.0%. And then you move the decimal 2 spaces to the left so that it turns into a pure decimal. So now we have 0.23. To find the percentage of the 275 students, you're going to multiply 0.23 times 275. And I'm sorry, this won't give you the percentage. It's going to give you the value of the percentage of 275. And if you multiply that, that equals 63.25 students. But of course, we can't cut a student into 0.25, so we can just round it down to 63 students. Although we have to be careful because when we're dealing with populations, sometimes we are asked to round up. So it's 63 students. You may see some places calling it 64 students. Next question, question number 2. If 500 students took the survey, how many can be expected to have 4 TVs in their house? So now let's go ahead and take a look. For 4 TVs, that's 20%. And it's the same process. 20% is the same as 20.0%. You can move the decimal 2 spaces to the left. And now you have 0.20, which is 20% in decimal form. Multiply that by your 500 students, and that's actually going to be 100 students have 4 TVs in their house. That's a lot. That's surprising. Okay, so for the next one, problem number 3, before we even do that, I'm going to set up something called the percent proportion so that you can determine how to read this. Okay, so the percent proportion looks like this. A proportion involves 2 ratios. A ratio is just going to compare 2 different things. So you could, compare like boys versus girls, or like pennies out of a whole dollar or something like that. But you have 2 ratios in an equation, and that's what we have right here. And that's why it's called the percent proportion, because it involves percents. Okay. Anyway, reading our story, we're going to go ahead and fill this out. It says 67% of the lowland gorilla's diet is fruit. So for our percent, that's where the 67 is going to go, because that's the percent space. The 100 is on the bottom because it's always out of 100% total, and the whole goes on the bottom. Okay. Anyway, so we have 67 over 100. Next sentence. If the gorilla eats 50 pounds of food each day, so right there, they said 50 pounds of food each day. That's like the total or the whole amount of food that they eat. So I'm going to go ahead and put 50 in the bottom because that's where the whole amount is. Now they're asking us what proportion can be used to find the amount of fruit eaten per day. So they want to know how much, like a small part of it. So this is a piece that's missing. Let's put it all together. If it's missing, we're going to use an unknown or a variable to represent the unknown, x. Now I'm going to rewrite this. So x, we don't know how much pounds of fruit that is, but we do know that they eat 50 pounds of food total that day, so that's the whole number. The percent we said was 67, and the whole amount was 100. So the option that satisfies this is option C.